We have sequences, which is just a list of numbers, and there's two main categories. So a sequence like this, and I'll give you the easiest kind I can, where you can pick up on the pattern, what's happening every time, adding to, adding to, adding to, or a sequence like this, multiplying by 2, multiplying by 2, Those are the two main categories of sequence. There's other sequences and other patterns in the world. We get it. But the two main ones that we'll be looking at are where you're adding the same thing every time, which obviously grows in what fashion? Maybe you don't know what I'm getting at. That grows in a linear fashion. But if you're multiplying by 2 every time, exponential, right? So this is 2 to the x power, and this one is 2x, right? I mean, that's not the formula, but 2x plus 1, that would be. And this would be whatever. So linear growth is when you add. Exponential growth when you multiply. So these, and we'll get to this, these are arithmetic sequences and these are geometric. But those are the two main types. Those are sequences. That's just the list of your numbers. Okay? And I'll ask you, what's the 57th term? I'll ask you, what's the 1,000th term going to be? And you've got it, and there's going to be formulas that you're going to be given for this. And same thing on this one. I'll ask you, what's the 100th term or what's the 1,000th term? It's not something that you're going to hit times 2 on your calculator 1,000 times to get. There's obviously shortcuts we'll learn. And then the series part is a new vocab word, but a series wants to know what happens when you add all of these terms together. What happens if I add the first 100 terms? So I want the series total through 100 terms. Or if I add the first 100 terms of a geometric sequence. That's what makes it, these are just sequences, and these are series when we add them together. Okay? And there's formulas for these on the reference sheet for the Regents that you will get. There's a formula for all 4 of them. Okay? And all of them are given to you except for this one. So there's 2 categories as far as adding versus multiplying. The type of sequence. And then there's 2 categories regarding if you're dealing with just the sequence. Do you want to know the 100th term? Or do you want to know the sum of all the terms through the first 100 terms? Big difference in the numbers that you're going to look at there. These are always going to be much bigger because you're adding them all together. If they're asking for the 100th term, that's just going to be what's the 100th item on the list. Versus the series through 100 terms is going to be all of these first 100 terms added together. And we'll see a bunch of word problems and help us, look into that. So that's the scope of the whole chapter. And we're just going to slowly jump into it with notation type stuff. So sequences. A sequence is just a list of numbers or expressions, usually with a noticeable pattern. Sometimes that patterns are pretty easy to pick up. Sometimes they're a little bit tougher to pick up on. But as far as these 2 main categories, I think those patterns are the ones we'll be looking for most often. Those are easy to pick up on. Okay. Here's like the notation. Okay. So if you are given a sequence, n stands for whatever number term you're on. So if you're on the 5th term, n is 5. So a sub 3, and that's how you would read that, by the way. A sub 3 refers to the 3rd term. A sub n refers to the nth term. A sub n minus 1 is going to refer to the, and we'll see this more as we move on, the previous term. So let's say n was 5. What would a sub n minus 1 be if n is 5? A sub 4. So a sub n, if n is 5, a sub n is the 5th term, right? A sub 5 equals 5th term. A sub 5 minus 1 is going to mean the 4th term. And that's where I'm like getting this previous idea. we'll see that and how it's used in a moment. But according to this sequence, it wants us to find a sub 1. In regular language, it's just saying find the first term. So to find the first term, you plug in 1. That's going to be 2 times 1 minus 1, which is 1. Find a sub 2 means find the second term. So that'll be 2 times 2 minus 1, which is 3. Find a sub 3 means find the third term. So plug in 3. 6 minus 1 is 5. And then find the 20th term. This means, plug in 20. So 2 times 20 minus 1 is 39. So what term would it be if it had a value of 53? So in other words, they're giving you this number. If this number is 53, what term would we be on? So if you go to the equation, they're giving you the value of some term is 53. And they're asking you to find n. Find which numbered item on the list it is going to be. So if you add 1 to both sides, get 54 equals 2n. Divide both sides by 2, you get n equals 27. The 27th term. What term would have a value of negative 101? Same idea, they're giving you the value. So negative 101 equals 2n minus 1. If you add 1 to both sides, you get negative 100 equals 2n. Divide by 2. So it's the negative 50th. Well, that seems odd, or should seem a little bit off, right? Because your first term is 1, and then 3, and then 5, and then ... First term, second term, third term. We obviously get up to the 20th term, it's 39, ... We get up to 53, that's the 27th term, and so on. To get to negative 101, we'd have to go backwards, which makes sense why n is a negative number, a negative 50th term. It would be like taking this pattern backwards is all. Okay? This notation that we just dealt with can also be written like this. However, we've been told by New York State that they're coming away from that format, which is good because this is 100% correct for sequences and series in math in general. I don't know why New York ever had us using that format, but everything should be given with this format, which has a subscript. That n that tells you which term you're on, that's a subscript, as opposed to an exponent, which is a superscript. Have you ever heard those two words before? An exponent is like a superscript. This is a subscript, because it's obviously written smaller and below. Kind of like in log notation. Our base of the log is a subscript. So this is a different type of sequence. This is a recursive sequence. And what's recursive is that it's kind of dependent on what happened with the term before. So this notation, anytime you see this n minus 1 as your subscript, this is recursive format. What it means is the term before. So if you're looking for a sub n, you need the previous term, a sub n minus 1, in order to get it. So this says to find a sub whatever, to find the, let's say, 100th term, you need a sub 100 minus 1, which would be 99. You need the 99th term and then add 5 to it in order to find the 100th term. You always need the term before or 2 terms before and so on. So this starts with a sub 1 equaling negative 2. Okay? So find the next 5 terms. So to find the second term, if we're using this explicitly, a sub 2 would equal a sub 2 minus 1 plus 5. But what happens with your subscript? 2 minus 1 is the same thing as 2 minus 1 is 1. 2 minus 1 is 1. So this is really saying in order to get the second term, I need to take the first term and add 5. And what was the first term? Negative 2 and add 5, and what do you get? 3. So the first term is negative 2. The second term is 3. Now, that was a lot of work, right? To show all that. That's why when I said earlier, when you're interpreting this, it's just the previous term and add 5 to it. So if a sub 2 is 3, what's the third term going to be if I just need to take the previous term and add 5? 8. And what's the fourth term going to be if I just need to take the previous one and add 5? 13, and then 18. And those are your 5 terms. Oh, it said the next 5 terms. So I got to go up to the 6th. Add 5, you get 23. Nathan. Correct. A trickier one, but yes. This kid. Fibonacci. God love you, Nathan. All right. Write a recursive definition for this one. Recursive definitions have to have 2 parts. You have to say what the first term is. So a sub 1 is 5. Because the recursive part is going to always rely on the fact that you know the previous term. Okay? So to find the nth term, you need to take the previous term, which is a sub n minus 1, and do what to it? Just double it. So take the previous term and multiply it by 2. Now, I'll be honest, anytime you multiply something by 2, that usually goes out in front. I just rewrote it. That's kind of the way you would see it. You're just doubling the previous term. So the definition down there at the bottom says a recursive sequence is a sequence whose subsequent terms, subsequent meaning follow-up, the follow-up terms depend upon the previous term. They must include a known value or a known term, usually the first term, and that's kind of including these 2 parts. Here's your recursive formula that tells you what to do with the previous term, but you also have to have a known value. So recursive terms, it's a lot harder to find the 100th term, because you can't just find a sub 100. Like, this is not a recursive formula. This is called explicit. And explicits are ideal because if I want the 100th term, I'm just going to plug in 100. Recursive formulas are tough because if I want the 100th term, if I just plug in 100, I'm going to get 2 times the 99th term. So I can't figure out the value unless I know the 99th term. And I don't know the 99th term without figuring out the 98th term. And so on and so forth back till I get to my known value. So recursives can be a nightmare. And just for the sake of time, they're not going to ask you to find the 100th term of a recursive sequence. Unless they've given you the 97th or the 98th, then they might. But if they've only given you the first term, they're not going to ask you for the 99th or the 100th term because it would take forever and a day. But an explicit sequence, they may. And that should take 2 seconds. Just plug in whatever term you're looking for. All right, so on the back here we have a recursive type situation. They give us a sub 1. They want us to find a sub 4. Well, we have to work our way up there. How do I know just by looking at this is recursive? What notation is in there? Right, this previous term notation. So to find any term, we need to take the previous term, square it, and add 2. So if I'm looking for the second term, I need to take the previous term, which was what? 2, square it, which gives me 4, and add 2, which gives me 6. Now I move on to the third term. To find the third term, I need to take the previous term, which was 6, square it, 36, add 2, 38. And for my fourth term, I need to take my previous term, which was 38, and I'm not going to square that in my head, 38 squared, and then add 2, 1446. The next exercise, still recursive. I've got a with a subscript of n minus 1 and n minus 2 in this situation. So a sub 3, if I do plug that in verbatim, what's 3 minus 1? A sub 2. What's 3 minus 2? If I plug in n of 3, 3 minus 2 is 1. So I need to take the previous term and add it to 2 terms ago, in this case. So the second term was 1, plus the first term was 1, and 1 plus 1 is 2. So you're taking the 2 previous terms and adding them together. So for a sub 4, if I plugged in 4, I would get a sub 3 plus a sub 2. There it is. I'm taking the 2 previous terms and adding them together. So that's the 2 plus the a sub 2, which was 1, and I get 3. I did. Yep. Good. Where have you guys seen the Fibonacci sequence? Just out of curiosity. Oh, so like a musical reference, and how do you know about it? Yeah, it's kind of a cool thing. We're not going to get too much into it, but I'm glad that you've seen it. A sub 5 is going to come from taking your a sub 4 and adding it to your a sub 3. So 3 plus 2 is 5. A sub 6 is going to take your previous term and adding it to 2 terms ago, which is 8. Now, if you just saw this written out, like the first term was 1, the second term was 1, the third term was 2, the fourth term was 3, the fifth term was 5, and the sixth term was 8, that's a sequence that's going to be harder to pick up on, right? You're not adding the same thing every time. You're not multiplying by the same thing every time. So it's a tougher sequence to pick up on the pattern.